Login accepted.
Hello, everyone. I will start today by asking some silly questions in the beginning, so forgive me. How many software developers do we have here in this room? Raise your hand. Okay. DevOps? DevSecOps? DevMLSecOps? Okay. You know, the whole idea of DevOps, DevSecOps, DevMLSecOps, was to bring great benefits, not only for us as developers, but as well for the business. And the business was really happy because they had to hire just one person instead of 4 when we are talking about DevMLSecOps. But the problem is that this concept did not deliver as it promised to deliver. I mean, in a lot of companies, there was a lack of talent pool, and the processes which were there were killing the whole idea. And therefore, they started to organize some internal infrastructure teams, which were responsible for builds, pipelines, releasing the applications, and so on. Nowadays, we are coming towards this platform engineering. Have you ever heard about platform engineering? Raise your hand. Yes, quite some people. And this, in the end, drifts us software developers, software architects, away from infrastructure topics. Before we start, short blah blah about myself. So I'm acting as fractional architect. I work on the basis of a daily cooperation, weekly, monthly cooperation. I don't work usually more. And I am open source contributor. You might have heard about evolutionary architecture by example repository that is written in .NET. And I wrote one booklet, Mastering Strategic Domain-Driven Design. And currently, I am writing Ode to Software Architecture book, which is a pragmatic guide for software architects. Meet the team, the product team. This team is to be developing the application, which is for sharing photos with other members of the application. And after deep dive in business analysis, the team started to think about numbers. And the numbers here are like, we have 10 million users. What in result gives us 1 million daily active users? So users who are really accessing our application. And each user makes 20 requests per day to our app. We serve in Europe 16 hours per day. And each user can upload up to 100 images with the each image size of maximum 5 megabytes. Does any of you remember the guys back in time who were hired in companies just to calculate infrastructure? It was before cloud. Raise your hand. 1, 2, 3. Yeah, not that many. But there were such guys. Nowadays, they are like dinosaurs. They are not anymore there because we have cloud. So in cloud, we can just do whatever we want. We can go with autoscale. We can live with that. And what I would like to share with you today are some concepts that sometimes are forgotten by us, by software architects and software developers, and are quite important from the perspective of infrastructure. And I will show you why in the end of this presentation with some surprise scenarios from this year. So when we have 1 million daily active users and each does 20 requests per second, we have 20 million requests per day. 1 hour, 60 minutes, 3,600 seconds. So it gives around 60,000 seconds, which we need to serve. And when we divide this total number of requests, it gives us 348 requests per second. Question 2, a lot or not? A lot, I hear a lot. Someone thinks differently? Depends. I heard it. So, when we deal with 348 requests, and each takes 2 milliseconds, and additionally, we can have multiple processing threads, it's not that many. We can handle them. But if we have 100 milliseconds, and we want to process it with one thread, would it be possible to process it within a second? Anyone? No, exactly. So if we have 100 milliseconds, we will need around 35 processing threads to process this 348 requests in a second. The next thing, which this team that you met in the beginning deals with, is a storage. We have 10 million users, and this 10 million users can upload a lot of images. Each user, 100. When we take into consideration that each image can be 5 megabytes of a maximum size, we should calculate it in a way that we always take the pessimistic number. And the pessimistic number here is 5 petabytes, 5,000 terabytes. Now, if we look at costs of storage, these are costs of one of the standard storages from the cloud provider, one of the most popular. And if we take a look at it, do you think it's a lot or not when we have 5 petabytes? Plus, minus? Can someone calculate it? It's a lot, 115K per month. And this is something that we need to be aware, because when we see that 1 gigabyte is just 2 cents, it feels like it's nothing, really, nothing. So probably we will have 100 gigabytes. But if our application gets traction and we don't have any limits, it might generate a lot of costs that we cannot cover. And the provider will say, hey, it's your job to deal with that and to guard it, that you don't generate such costs. The team started to think about the structure of their system. They knew that they can't handle this 350 requests per second with a single instance. It's not possible. So they started to think, okay, we need to deal with distributed system. And the problem with distributed system is that it communicates over the network. Has any one of you heard about the CAP theorem? A lot. Perfect. CAP theorem says that for any distributed data, you can guarantee 2 out of 3 characteristics which you see on the screen. One characteristic is about availability. Second is about partition tolerance. And third, about what? Consistency. Thank you very much. And partition tolerance is something that we have to deal with because network is full of failures. In case we don't deal with partition problems, we could say that you can have any combination of those. So you can have AP, partition tolerance availability, you can have CP, consistency and partition tolerance, or you can have CA, consistency and availability. But this CA, in fact, in practice, it's not possible when we are dealing with network failures. Something just came to my mind, and I know that probably most of you have already faced such situation. You come to the business and you ask a lot of different questions. You handle business analysis and so on. And you ask also, should our system be available always or always consistent? What would be the answer? Both, exactly, both. And then you start describing this concept that you can't have it. You need to choose between them because CA is not possible with network failures. And they say, fix the network failures. And then I think, God, give me patience, really. So when looking at example of what can go wrong, we have a user and another user. They are pointing to our API. One API which is responsible for reviews. Now, one of these instances, which is just a replica, is not answering. So we have two choices. One choice is that we want to keep it consistent. Is it important for reviews of the product? Not really. Same goes with comments. So for comments, if you have some article and then you have comments, if someone sees a different state of the comment, it's not a problem. But if you can't see comments or you can't comment the stuff, then it might be a problem. So here we would go into availability. And that's a very important thing here to remember that you can have in one system, you can have different models. You can have CP, you can have AP, no problem. Combine where it is needed. The second example is with the product catalog. And in product catalog, we have check for the availability of the product. So you can see that there are 10 products, let's say, or 90, or 3, or 1, or -1 if there is no check like required. And now, if one of these instances is gone, all the users are pointing to the first instance. And the number of the stuff decreases, decreases, decreases. So in the end, we have availability 1. What can happen now if the replica, another instance, wakes up? What can happen here? This can happen. So if there was no synchronization yet between two different instances, you will have incorrect state of the system. So maybe in such case, it would make more sense to stay consistent instead of having the available model for availability. Do you see any problem with CAP theorem, which says consistency, availability, and partition tolerance in modern systems? We have our product catalog, and this product catalog checks the availability. Perfect. We have available modules, available instances. So the availability instance is available, and we can call it. But what is wrong is that we can get the response 1 week later. Of course, in systems, real-world systems, we don't wait 1 week. But if it is 30 seconds to get the response, this means that this system is available or not. What do you think? Would the user leave your page if he can't get the answer in 30 seconds, or he will stay? Exactly. So that's the first problem of CAP theorem. It does not take into consideration latency. Second thing is that when we have system where there is main database and 2 replicas, and we are writing to the main and reading from replicas, what happens if we can't write, but we can still read? Is the system available or not? Hard to say. Hard to say. So that's why you might know the guy who is Martin Kleppmann. Do you know this book? It's a great book. Really, I recommend reading it. And what he introduced is some kind of a document where he tells about the delay sensitivity. So we are thinking about latency-centric concept, and this paper is available with this QR code, and we don't look just at availability or consistency. Next, the team decides to go into cloud, and they realized that some people, or most of the teams inside the organization, they use one cloud, in this case, Azure. But we have more skills in our development team towards AWS. So our team goes AWS. We got approval from the business, and that's fine. After 1 year, business comes back and they say, we decided for entire organization that we all want to go with one cloud provider. So what you need to do now is to go to Azure. And the problem which you face there is that if you deal with services directly from Azure, you have a vendor lock-in. And when you have vendor lock-in, it will be quite hard to migrate to AWS. Because in a year from the development start, a lot can happen, and it might be quite tough to migrate. Scenario number 2, we are serving Europe, as in the described case. We are going cloud-specific way with Azure. We add all the stuff like functions, Cosmos DB, AI services, OpenAI, Kubernetes, app service storage, whatever. Now the business comes and they say, hey, we want to serve it as well in China. And the problem with such countries is that usually they have their own clouds. And they don't want to go with Azure, AWS, or Google Cloud provider. Sometimes they can, they accept it, but a lot of cases is like they can't accept it. And now, what happens? Yes, not going to China, but if China provides or buys most of your products, you can't just say, okay, we can't go there, yeah? So what you can do is focus on the cloud-agnostic approach. I'm not saying it's always the best case because there are no silver bullets. Sometimes it's better to go cloud-specific way. Sometimes it's worth going cloud-agnostic way from the beginning, especially when you are working for large-scale organization where you have a chance to migrate to different clouds, where you have chance to have customers from countries like China or Russia. Then it makes sense to think about the cloud-agnostic approach. So therefore, you can host all these things on your own. You can have RabbitMQ, you can have Postgres, you can use OpenAI or any other provider from the perspective of artificial intelligence. You can use Grafana and Prometheus, or Kubernetes or K3s. Who knows K3s? Because, okay. Already quite a lot of people. Cool. I promised my colleague that I will ask this question during this conference. So with cloud-agnostic approach, there are several pros, but also cons, as always. First of all, we don't have any vendor lock-in, and the cost of migration to another cloud will be lower, for sure. The problem which we have is that we have higher upfront costs because we need to do everything on our own, and we can't just use services that are semi-configured. And additionally, it requires more expertise. It's way easier to just grab, let's say, app insights and use app insights, by the way, which are quite expensive, rather than setting Grafana Prometheus from scratch. Another thing is service level agreement. From service level agreement, we have a lot of different factors that we can measure. And one of the most popular ones is availability. Our business comes to us and they ask us, hey, we need 99.5% of availability, 295. So in a basic scenario, we have users and these users are calling our app. It's 99.5% of uptime. But now we have a little complication. We added as well a database component, which is another 99.5%. What would be the availability now of such system? No replicas, no failovers, no fallbacks, nothing. 99%, and it's called combined availability. When you deal with this multiple components, you just multiply it. And now what we can do to save ourselves is to use a mechanism which is called fallback. With fallback mechanism, you are using just a completely different component that you have today. So if we have a database, and let's say it's Postgres, we might use another component which can be MongoDB, and with its own availability, we can have some file-based system, whatever we want. And this way, when we are calculating the availability, first we focus on the component availability. And component is the primary one and fallback one. If we take it into consideration, we have a calculation of 99.99% for the system with this fallback mechanism. Now, when we have the component availability, we can calculate again the combined one. With combined one, we have back 99.5%. And another thing which you can do is to have a failover. With failover, we talk about another instance. If we have Postgres database, we have just another instance of it. If both have 99.5% availability, you calculate it exactly the same way as with fallback. They calculated all the stuff, and now they started thinking about continuous deployments. Who uses continuous deployments? Several of you. Yeah. Great thing. It's a great concept. I would lie to you if I would say that, hey, I don't like it. I love it. I love it. But it has some consequences. So imagine that we have Mark and Jacob, two programmers who are working together. They are doing pair programming. And when they are ready with the change, Mark pushes changes to main. When he pushes these changes to main, it triggers pipeline. And in this pipeline, we have build and we have verification checks, like static code analysis, infrastructure analysis, unit tests, integration tests. Then it triggers the deployment of production candidate, and after we are running acceptance tests, it can be promoted to production, of course, if they are successful. Now, it's a great mechanism, but it costs money. And often, organizations cannot accept not only the fact of money, but also the fact that they have already someone who will approve all the releases or all the deployments. And this guy works in the company for 25 years, and he does it since 1999. It's hard. Sometimes it's really hard to introduce it. What you can do is that you can introduce continuous delivery. So still, you can have this guy who will accept the release, the deployment. And this is a David. And David will trigger the production candidate. And again, all the verification checks, acceptance tests will go through, and it will be promoted to production. What works really well is that you can use this continuous deployment concept. If your organization is not willing to move on production, you can create kind of a staging environment where the continuous deployment goes on every single time, which is a replica of production, but it again brings more costs. Now, when we are thinking about this continuous deployments, continuous deliveries, and so on, we have several different strategies that we can use. One is blue-green. Anyone uses blue-green? Okay. It's usually offered by cloud providers, even in services like app service. So we have 100% users who are accessing either blue or green environment, which is currently a prod. And then development team deploys another environment. Users can still access the previous one. And after successful checks, it is promoted. So this new version is promoted to production, and all the users' traffic is accessing the production, which is now green. And they just replace green, blue, green, blue, green, blue, green, blue. Then we have canary releases. Anyone using canary releases? 1, 2, it's so dark here. Around 3 guys. So with canary releases, we have the version of the application, which is currently running on prod. And now we are deploying the new version, but we don't push the entire traffic to the new version after successful checks. We are just increasing the amount of users that are accessing it. So now, first, we can do 5%, 10%, and we can observe what goes on. We can do automatic checks of this, or we can do the manual observation if we are willing to. And for example, if we see that within an hour, we have a lot of 400s or 500s, we can just cut out this canary release candidate and go back with full traffic to the previous version. This is one of the ways. Another strategy is rolling deployment. Anyone using rolling? Yeah, more than canary releases. So with rolling deployment here, it's like 33% of traffic. To just simplify the case, we have version 1. After update, we are updating just one of the instances that are running. Then 2 instances, 3 instances, of course, if everything is OK. If something is wrong, then we cut out this new version. What do they all have in common? Canary releases, blue-green deployments, and rolling ones. Easy rollback? Mm-hmm. Exactly. And this easy rollback, who worked with blue-green canary releases or rolling, it's not that easy if we are talking about the database. So let's look at the scenario. We have a table. Table is named patients, and we have there some information about patient, like first name, last name, phone, date of birth, few other columns, and the assigned code, magical number. Now, there is a new requirement that we need to change the type of this assigned code column from numeric to text, because it can now contain also letters. First version of the application is reading and writing to the assigned code column. So when anything new is coming in, they are storing it in assigned code column. When they need to read, they read it from it. Now we introduce version 1.1. And this version 1.1 can do it the way that it is still reading the assigned code, but it is already reading and writing also from the assigned text code, which is a new column next to the assigned code one. Now, if something goes wrong, the application in version 1.0 can still read from the assigned code when we are dropping application 1.1. 1.2 is migrating already the data from the assigned code column to the column assigned text code, and also continue writing new codes. As you can see, it stops reading from it. Now, version 1.3 drops the table. So in case anything is not working with application 1.3, we can remove the version and go back to application 1.2 because it does not use this assigned code. So it's always step-by-step migration, and we need, in case of continuous deployments, continuous deliveries, we need to figure out and prepare an entire plan for the migration of the data, that in case something goes wrong, we can go back to a different version. When working with software systems, it's also good to observe them. There are a lot of metrics, a lot. But today I would like to focus on something called DORA. And this DORA is introduced by Google, was introduced by Google. Anyone working with DORA? Cool. It focuses on the deployment frequency, so how often do we deploy the application? Second, we check the change failure rate. When we are deploying and there was a failure, we are calculating it, counting it into the bag of failed deployments. There is lead time for changes, so how long does it take us to add a change to production? And the fourth one, time to restore service. In case of failure, how fast can we restore the service? And there are two teams, Team A and Team B. As you can see, Team A goes the old way, and they do the 4 times per year deployment of the application, while Team B is doing it 1,000 times per year. This means that they have probably multiple deployments per day. But if you are from the business, does it change anything? Really? Okay. What? Mm-hmm. Okay. Change failure rate. I am from the business, I am looking how did they perform. And now I see that, hey, Team A did great job, 0% of failure rate. But Team B failed 30 deployments out of 1,000. Usually, for non-technical guys, this gives like an overview that, hey, Team A is really great because they are green. They are green in Excel. The Team B is red in Excel. And that's why there are 2 other metrics. Lead time for changes. Team A needs 1 week to add a change to production, while Team B does it in 2 hours. Does it bring value to business? A lot. A lot. First, we can validate quickly our application, our features with users. We can gather, collect feedback from our users, and we don't burn money by developing something for 1 month or 2 months. We are just doing it up in time. And the last one, time to restore service. Team A needs 3 hours because there is a lot of manual work. They need to run some scripts, they need to click here, they need to remember that there was something on SharePoint, and they need to find this document to just check what do they need to do. Team B is doing it in 3 minutes because everything is automated on their side. And by using these metrics, I don't say you have to do that, but this is perfect example of something that you can show to non-technical people after a year, after 3 months, 6 months, and tell, look at numbers. This is not based on gut feelings. This is plain, pure number that you can base on, and I recommend to just try it. And now the part that I couldn't wait to show you. Surprises. Have you seen it this year? There was a guy who hosted static site, and he was attacked with the attack of the DOS. And it generated $100K bill for a static site. A lot? A lot. And that's why I always say, read documents, read pricing, not only the shorter ones, but also the detailed ones. Because as you can see here, the Netlify has a starter pricing tier, and the bandwidth is 100 gigabytes per month. The problem is that after you cross it, it's $55 per 100 gigabytes. And as default, it is not turned off. So you have to turn it off. That's why it's so important to read the documentation. Another one, it happened like 1 week ago. Have you heard about Kara app? It went viral. It's like for sharing photos, like in our application. And they started using serverless, but no one did the calculation of what can happen. They didn't have as well any limits. If they would have done the calculations, plus minus, because you can't do calculations always, which are exact of what you will have in your bill, if they would have done it, there wouldn't be the problem of 100K bill. The problem was that they have no money. At that point, they had no money to pay this 100K. I know that at the moment they are looking for some investors. Probably they will find them, but it's just to always check what you are using. One more thing, be careful. Be careful of free credits. When you are starting your company, you have a great startup idea. Cloud providers usually can provide you several $100,000 to use in the first year or 2 years. The problem is that it's a vendor lock-in. You want to use this service, another, because it's easy. You are just adding it. You have a lot of money. You have several $100,000. But after 2 years, you have to pay it. And now you have a choice. Rewrite it, go, for example, with cloud-agnostic approach, maybe semi-cloud-agnostic, some parts keep in the cloud as services, or pay the money for your bills. There are some supporting tools that can help us with the infrastructure. One of this is Checkov. Checkov is for free. It's completely free. You are plugging it into pipeline, and it can validate your infrastructure in cloud. So if you have Terraforms, one of the supported things is Terraform. So if you have Terraforms, it can automatically check that, hey, man, you've forgotten to turn this setting off, or turn this setting on, or this is not the way how it should be done, and so on. It gives a lot of benefits completely for free. You can connect it to your pipeline as a Docker image, and then it will run every single time the pipeline starts. Second one, SonarQube. Probably most of you know the SonarQube. Am I right? Raise your hand. Yeah, quite a lot. SNCC, developer security software. Yeah, it's recommended to do that, to use it. Really, like maybe you don't need to use it on a daily basis because, yeah, maybe it will cost you too much. But however, there is free tire in pricing, but it's worth to run it from time to time. It can show you a lot of security vulnerabilities in your code base. And the last one, which I really love, it's related to performance. You can run load tests, so you can check your application. If you expect 10,000 users, you can run the load test, let's say, with 11,000 users or 12,000 users. You can also go with stress tests to check your architecture when it will fail. So maybe if you are supporting this 10K users, you want to run it for 50K users because you observe that the application is getting traction and you want to check the point where your architecture will fail. And to sum up today's talk, I would like you to remember that even if the world goes into platform engineering, you can still do things as software architect, software developer, which are related to infrastructure. And you should check the numbers. You can check how you want to handle this cap with consistency, availability, and so on. Because it doesn't mean that the infrastructure topics just came somewhere else and are not anymore on our shoulders. My grandpa had that saying that when one door closes, another opens. However, he wasn't a good carpenter. Thank you for joining my presentation. If you are interested in the book, you can scan the QR code and, yeah, enjoy.